what you see is a source. I'm gonna put sources over here. How can I find the magnitude of the force, say, d distance away from the sources? I have to put a pointers. So if I put a tiny pointers right here, will allow me to find the magnitude of the force created by these sources.
So let's find the force between them. So electrostatic force between them is Kq small q over r squared. So K is 9 times 10 raised to 9. This is 1 coulomb. And this is 1 microcoulomb. 1 microcoulomb 1 times 10 raised to 96 divided by 9, 3 squared. So electrostatic force between these two is just 1000 Newton. K is 9 times 10 raised to 9. Big Q is 1. R squared is 9. So electric field is 10 raised to 9 Newton per coulomb. This is the electric field right here, 10 raised to 9 Newton per coulomb. Now we're going to use it. We're going to find it 10 times -6. So electric field is 10 raised to 9 Newton per coulomb. And let's confirm. So two different ways to find the electric field. Q3, there is Q2, which is 0.2 meter away from Q3. And then I have Q1, which is, let's say, 0.3 meter away from Q2. This is -8 microcoulomb. What I want to find is what is the electrostatic force on Q3 due to Q2 and Q1. So let's find it. Electrostatic force on Q3 due to Q1. What does that mean? Okay, Q3, then Q1 over R squared. Alright? So K is 9 times 10 raised to 9. Q3 is, of course, 94, 10 raised to -6. And Q1 is -8, 10 raised to -6. Everything divided by 0.2 plus 0.5. 0.2 plus 0.3, 0.5. 0.5 squared is 0.25. So this is going to give you 1.2 Newton, which is deposit. Why deposit? Because this is negative and this is negative. They deposit each other. So now let's find Q3 again, 94 times 10 raised to -6. And Q2 is, this time is positive, 3 times 10 raised to -6. R squared, so 0.2 squared is 0.04. So 7 Newton attractive. Why attractive? Because this, let's put negative here. Why attractive? Because this is positive. Because this is negative, this is positive, they attract each other. Okay. Now we're gonna find the net. So what is the net electrostatic force? So let's draw the Q3. So green one is how much, and what is the name of the green one? So let's see. The name of the green one is F32, and the magnitude of the green one is 2.7 Newton. What is the name of the other one? Name of the other one is F31. And what is the magnitude? 1.2 Newton. Okay, so then what is the net force? Net force, F net is, this is negative 2.7 plus this is positive 1.2. So 1.5 Newton to the west. What does that mean? That means there is a net attractive force between Q3 and Q2.